This is Chemistry for Grade 10. Produced by Tigray Education Bureau. Transmitted by Dimtsi Weyane Tigray National and FM radio satellites and social media. And also FM Maqala 104.4.
Hello, students. Welcome to Chemistry lesson in Grade 10, Program 5, presented by Brahana Hagus. Students, let us start from the previous lesson by revising what you have learned in the previous lesson. Students, in the previous lesson, we have learned the definition of galvanic cell. Galvanic cell is an electrochemical cell which converts chemical energy into electrical energy. Galvanic or voltaic cells are classified as primary, secondary, and fuel cells. Primary galvanic cells are cells that are not rechargeable, and the cell reaction cannot be reversed, and also the original reactants cannot be regenerated. Examples of primary galvanic cell: Daniel cell, zinc carbon dry cell, mercury battery, lithium battery, alkaline cell, copper oxide cell, mercury oxide cell, etc. In zinc carbon dry cell, the zinc cap is filled with a paste of manganese 4 oxide, zinc chloride, ammonium chloride, and powdered carbon. Moist paste of ammonium chloride with manganese 4 oxide acts as the electrolyte in zinc carbon dry cell. Secondary galvanic cells are rechargeable cells. The cell reaction can be reversed and the original reactants can be regenerated. Lead storage battery and nickel battery are examples of secondary galvanic cell. In lead storage battery, the anode is lead, the cathode is lead 4 oxide, the electrolyte is sulfuric acid. Electrolysis have the following applications in industry: A, for the production of chemicals like sodium hydroxide from brine; B, for the production of metals and non-metals like non-metal hydrogen, fluorine, etc., and metals like aluminium by Hall process. C, for the purification of metals like copper, sodium, magnesium, calcium, etc. And also, electrolysis is very important as electroplating. Students, today you will learn about chemistry in industry and environmental pollution. Let us proceed to our today's lesson. Unit outcomes. After completing this unit, you will be able to know the renewable and non-renewable natural resources and appreciate their importance to industry as a raw material. Second, know the extraction, chemical property, and use of aluminum, iron, copper, nitrogen, phosphorus, oxygen, sulfur, and chlorine. 3. Know some chemical and related industries in Ethiopia. 4. Understand the important steps in the production of glass, ceramics, cement, sugar, paper, and pulp. And also, you know how tanning is carried out and how food is packed and reserved. Introduction. A chemical industry is an institution involved in the production of chemical products. Generally, chemical industry uses naturally available raw materials to produce the desired product. Second, chemical industry involves a chemical reaction to transform raw materials into finished and semi-finished products. 3. Chemical industry consume relatively large quantity of energy during the manufacturing process. 4. Chemical industry use safe operation methods in their manufacturing process, and chemical industry tests their products during and after manufacturing in their quality control or laboratory to ensure that the products meet their required specification. Students, let us proceed to natural resources and industry. After learning this subtopic, you will be able to define natural resource, list natural resources, classify natural resources as renewable and non-renewable resources. Natural resources are resources or materials that exist in nature and available in nature for people and to consume directly or after processing. Example: minerals, soil, water, trees, air, food, crops, petroleum, natural gas, mineral coal, animals, etc. are some of natural resources. Natural resources can be classified as renewable and non-renewable resources. Renewable resources are resources that can be replaced or regenerated by natural process. Thus, resources can be renewed at the same rate at which they are used. Plants, animals, soil, and water are some examples of renewable resources. Non-renewable resource. Non-renewable resources are resources that are found in a fixed amount in nature and cannot be replaced or regenerated. Thus, resources can be completely used up within some decades and cannot be replaced easily. Example: petroleum, coal, natural gas are some of them non-renewable natural resources. Students, here are some questions and also try to classify which are renewable natural resources and which are non-renewable natural resources. Ready? A. Petroleum. B. Minerals. C. Firewood. D. Biomass. E. Plants. F. Coal. G. Animals. H. Natural gas. Okay, students, have you tried it? Very good. Let us discuss together. Among these questions, renewable natural resources are C. Firewood, E. Plants, G. Animals. Thus, non-renewable natural resources are A. Petroleum, B. Minerals, D. Biomass, F. Coal, H. Natural gas. Have you answered like this one? Very good. Let us proceed to occurrence, extraction, and use of aluminum. Students, after learning this subtopic, you will be explain the occurrence and extraction of aluminum, describe the main physical and chemical properties of aluminum, list use of aluminum. Students, I think you are familiar with the symbol, atomic number, atomic mass, group, and period of aluminum. Very good. Let us discuss the occurrence and extraction of aluminum. Aluminum is the most abundant metal and the third most plentiful element after oxygen and silicon in the Earth's crust, about 7%. It is the second most important metal after iron in terms of consumption. Aluminium does not occur as free metal in nature. Its principal ore is bauxite. Other minerals containing aluminium are orthoclase, cryolite, corundum, beryl, kaolin, mica. Students, from your textbook, you should follow the chemical formulas of the ores of aluminium. Aluminium is extracted industrially from bauxite by the Hall process. In this process, first, the bauxite needs to be purified, frequently contaminated with silica, iron oxide, and titanium 4 oxide. To isolate pure aluminium oxide from bauxite, the powdered ore is first heated with sodium hydroxide solution to convert silica into soluble silicate. The reaction is silicon dioxide plus sodium hydroxide gives sodium silicate plus water. At the same time, aluminium oxide, which is Al2O3, is converted to soluble sodium aluminate, and the reaction can be written as Al2O3 plus sodium hydroxide gives sodium aluminate plus water. The impurities like iron oxide and titanium 4 oxide remain unaffected by the base and are filtered off. Why they are not affected? Because those impurities does not dissolve in the base. Then the solution treated with acid to precipitate aluminium hydroxide, and the reaction is aluminate ion plus hydronium ion gives aluminium hydroxide, and aluminium hydroxide converted to Al2O3 or aluminium oxide by filtration, washed, dried, and then heated strongly in the furnace, and the reaction will be aluminium hydroxide plus heat converts to Al2O3 plus water. Pure aluminium oxide is mixed with some cryolite and then melted. The molten mixture is then electrolyzed to obtain aluminium using electrolytic cell. Students, here are some questions, and the instruction says choose the correct answer from the given alternative. Number 1. Aluminium is extracted industrially from A. Kaolin, B. Bauxite, C. Beryl, D. Orthoclase. Let me repeat the question. Aluminium is extracted industrially from A. Kaolin, B. Bauxite, C. Beryl, D. Orthoclase. The answer is B. Bauxite. Number 2. The process of extracting aluminium from its ore using electrolytic cell is A. Contact process, B. Ostwald process, C. Hall process, D. Frost process. The process of extracting aluminium from its ore using electrolytic cell is A. Contact process, B. Ostwald process, C. Hall process, D. Frost process. The answer is C, Hall process. 3. The main advantage of adding cryolite to aluminum oxide is A. To increase the density of aluminum, B. To increase the melting point of aluminum, C. To reduce the melting point of alumina, D. To reduce the boiling point of alumina. The main advantage of adding cryolite to aluminum oxide is A. To increase the density of aluminum, B. To increase the melting point of aluminum, C. To reduce the melting point of alumina, D. To reduce the boiling point of alumina. The answer is C. To reduce the melting point of alumina. Let us proceed to properties of aluminum. Physical properties. Aluminum is a soft silvery white metal having a density 2.7 gram per cubic centimeter. It melts at 660 degrees centigrade and boils at 2467 degrees centigrade. It can be shaped into wires, rolled, pressed, or cast into different shapes. And it is a good conductor of heat and electricity. Chemical property of aluminum. Aluminum is a very active metal, but it is not as reactive as alkali metal and alkaline earth metals. Aluminum shows the following chemical reaction. A. Reaction with oxygen. Aluminum is a self-protective metal that resists corrosion. It reacts with atmospheric oxygen and forms a thin film of aluminum oxide on its surface. And the reaction given by aluminum plus oxygen, Al2O3. The thin film of aluminum oxide serves as protective film and prevent further reaction with oxygen. The thin layer can be removed by rubbing with mercury or mercury 2 chloride solution. B. Reaction with dilute acid. Aluminum reacts with diluted acid like hydrochloric acid, sulfuric acid, but it cannot be reacted with nitric acid due to the formation of a thin layer aluminum oxide. C. Reaction with chlorine gas. When aluminum burns in chlorine gas, it forms aluminum chloride salt, and the reaction is aluminum plus chlorine, aluminum chloride salt. D. Reaction with sodium hydroxide. When aluminum reacted with sodium hydroxide, aluminum forms soluble sodium aluminate and release hydrogen gas. The reaction given by aluminum plus sodium hydroxide gives sodium aluminate plus hydrogen gas. Students, today you have learned about renewable and non-renewable natural resources and occurrence and extraction of aluminum, and also you have learned properties of aluminum like physical property and chemical property. Next time you will be learn use of aluminum and occurrence, extraction, properties, use of iron. Until next time, goodbye.